Hi guys, and welcome back to this lecture 6 already. Final section, our final lecture on our fundamentals section. In this lecture, we are going to cover variable scope and error handling. Should be great fun. Again, this is part of the fundamentals section, so we're going to move through quite rapidly, assuming you've already been exposed to all this stuff. If for any reason this is new to you, please feel free to go through this a little more slowly and or multiple times. You've got that script there, so go ahead and study those if this is relatively new to you. Okay, let's jump on the inside and take a look at Lecture 6 script.txt, and we'll learn a little about scope as well as error handling. We'll catch you on the inside.
We begin by defining a package. A PLSQL package is an object which serves to contain other subroutines. In our little example here, our package is called scope example, and it contains two procedures called scope example 1 and scope example 2. Go ahead and copy that guy into SQL Developer and then hit this little icon here to execute the script. Ta-da! We've created a package definition. Now, a package definition by itself really doesn't do anything because it doesn't really have any associated code. The code part comes within the package body as shown here. Again, go ahead and copy this guy into Developer and hit the Execute Script icon to compile our scope example package body. Let's take a quick look at our package body and see what this guy actually does. Looks like it starts out by defining a variable named myVariable and assigns it a default value of package. Now, because myVariable is defined outside of either of the procedures, the scope of myVariable is by default global to the entire package contents. That is, any procedures defined subsequent to this variable have access to it without being specifically declared within that procedure. Given that information, what do you expect to print if we execute the scope example 1 procedure from within our scope example package? Guesses, anybody? Of course, procedure scope 1 does nothing to redefine our global variable, and as such, it simply prints out the globally assigned value of package. So how do we make variables available to all the subroutines within a package? We define them within the package body prior to those other subroutines. Net, they become global variables. Furthermore, those variables can be of any complexity. Here we're just using a simple varchar primitive, but we could have just as easily defined a bunch of complex user-defined types and made those structures globally available to all the package-bound routines as well. Handy? You bet. All right, let's go ahead and go back to our package body definition and take a look at the code associated with the scope example 2 procedure. Looks like the scope example 2 procedure starts out by declaring a new variable with the same name as our global variable, that is myVariable. In addition, our scope example 2 procedure assigns this new variable a value of modified in example 2. Okay, fair enough. Anybody want to guess what happened to the scope of the myVariable variable? Of course, it has now been redefined to only the scope of the scope example 2 procedure because therein it was redeclared. Anybody want to guess what value it would have had in scope example 2 procedure had it not been assigned a default? Of course, it would have assumed the value null. Moving down the declaration block of the scope example 2 procedure, we see a locally declared procedure named scope example 3. These things are commonly known as a nested procedure. Yes, you can nest subroutines definitions to any level in PLSQL. Looks like our scope example 3 procedure also redeclares the my variable and assigns it a value of modified and nested. Well, I'm guessing you already know where all this is going at this point, given that it's a lecture on scope. We are now going to execute our scope example 2 procedure and watch the value of our initially globally defined variable change as its scope is changed from the package to the scope example 2 procedure, and then finally to the nested scope example 3 procedure. Hey, come on. I know it's a trivial example, but so is scope, so let's just move on to error handling. I'm sure I don't need to tell all you guys about the 2 types of errors which can occur within a piece of code. And here I'll code jocks yourself so you already know the answer. 1 syntactical and 2 logical. 1 I typed in wrong or made a syntax error, and 2 I have all the syntax right, but it doesn't realize my intended goals. I'm doing something wrong. However, just for the sake of educational completeness, let's take 30 seconds on syntax or compilation errors. So let's go ahead and copy the procedure named error examples into developer and hit the execute script icon. Not surprisingly, given the procedure's name, we compile with errors. Shoot. Well, now you could sit here in this generalized work area and try to figure out where your typos and or syntax errors were, but a much more efficient place to debug code is in developer's built-in procedure editor, so let's jump over there. If you look over here on the left-hand side in developer, you'll find a tree structure of all the objects in your schema. Under procedure, you'll find your error examples procedure. Double-click that guide and it'll open up in Developer's Procedure Editor. By the way, you'll see the rest of these procedures a little later in our lectures, but for now, I want you to notice the differing icons associated with these various procedures. Looks like the error examples procedure was compiled, but still has errors, thus the red X out icon. My insert XML game files and tester procedures were successfully compiled with the debugger enabled, thus the little green bug icon. And the read game files and wait team plays procedure was successfully compiled without the debugger. Okay, let's start by fixing the syntax errors associated with our error examples procedure. Easiest place to start once you have it loaded in the subroutine editor is to compile with debug from up here at the top. The IDE does a very nice job of telling you where you can find those syntax errors. Looks like I've got 2 syntax errors, one on row 2, column 5, and the second at row 5, column 12. Let's check those guys out. The message associated with my error on row 2 says it was expecting one of a set of possible keywords or identifiers. Well, guess what, guys? Left off the keyword is after my create procedure statement. So let's go ahead and fix that guy up right now. Next syntax error is equally easy on row 5. I have my assignment operator wrong. Rick, this is not ASP.NET, so I need to add that colon back into my assignment operator. I make this little fix and recompile, and I have a syntactically correct procedure despite its name. Okay, now we're going to start looking at the much more interesting logic errors. We all know what these bad boys are. They're bugs. Whether it's something as simple as a rounding error or as complex as miscalculating a statistic, these are the ones we all hate because they're very difficult to find and sometimes very difficult to correct. Let's start with something very simple, but otherwise improperly handled. Here's our code. We're intentionally going to do a division by 0 without proper error handling. Let's just run this guy and see what kind of mess we have otherwise thrown at our poor end users. Okay, aura 01476 divisor is equal to 0. Hey, that shouldn't scare anybody, right? The old Aura 1476 trick is something just about everyone should know by the time they're a teenager, right? Wrong. Nobody should ever be expected to interpret these crazy Oracle air codes except us geeks. So, how do we go about handling this mess? Well, handling is exactly the correct word. We need to write an air handler. In this little example here, we're adding an air handler with one explicitly handled air condition. That is division by zero. What's the truth? Nobody in their right mind would write an air handler like this because it knew division by zero was a possibility. You would have rewritten the code with a conditional to avoid it. A more likely scenario is to write code something like this for debugging and then try to get all those nasty bugs out now before we publish. You know, with today's professional software testers, getting truly clean code out to the users is a requirement. The use of SQL code and SQL error message here is perfectly acceptable because it helps us debug. But please never run this kind of stuff to the end users. These kinds of error codes are just too scary. However, once this code is fully tested and ready to go to production, I would go back in and make a final change to the air handler. I'm going to assume that the code is correct now and that any error is a result of a change in the database environment, table space is full, mirroring issue, something like that. As such, I'm going to insulate the user from any Oracle error message and just give them contact someone in IT. Then you can put those SQL code and SQL error message back in and retest and see what changed. Maybe you did miss a bug, or maybe something in the database environment changed that you need to accommodate. Either way, if it's me, I'm not going to expose the poor end users to those nasty Oracle messages. We just send them back to the DBA to tell them we've got a problem.
All right, welcome back, and I hope you enjoyed that little lecture on variable scope as well as exception handling in PL/SQL. Real straightforward stuff. We're going to, in the next lecture, jump into triggers where we finally start looking at some real world code. All right, so what did we learn about scope? Scope is that section or block of code over which a variable is valid. We looked at a package that contained a couple of different procedures. We originally defined a variable at the package level, which had a scope of the entire package. That is, anything within that package could reference that variable. We then looked at a procedure within that package which redefined or redeclared that variable to a new value, thus changing its scope to just that procedure. And finally looked at a nested procedure within a procedure and did a further redeclaration there, thus diminishing its scope just to that nested procedure. Should be reviewed for all of you, I expect. Scope is second nature to everyone here in this, listening to this lecture. We then looked at exception handling. I go at it a little differently than they tell you in the Oracle classes, official Oracle classes. They'd have you explicitly identify and handle exceptions by an exception name. I'm not a big fan. I think those exceptions that Oracle throws are too scary for typical end users, and as such, my standard is to use the SQL error code and SQL error message during the debugging phase, but then just route any subsequent errors to the DBA's attention. Normally, you shouldn't be putting through errors anyway, and as such, when an error does get through in these days, it's typically a function of the database environment, something screwy with the RDBMS. We've either run out of table space, or mirroring has failed, or something physical typically occurs. With professional software testers anymore, there's just no excuse for letting software go into production with bugs in it. So let's hope you don't either. All right, that puts a wrap on this lecture. In the next lecture, we're finally going to start looking at some real-world examples, and in particular, we're going to look at triggers. We'll see you then. In the interim, hey, you go out there and you have some fun, but learn something every day. It's what's important.